Good afternoon, dear students. I hope my voice is audible for you people. Yes, today we are studying the important questions that is from the chapter Magnetic Effects of Electric Current. Yes, this is the chapter, one of the important chapter that belongs to the physics section. So in this chapter, what you learned, just recall what you learned in this chapter. Already you know that the magnetic effects of the electric current, how the electric current produces the magnetic field and the characteristics of the magnetic field lines. So very importantly, you have studied about the characteristics of the magnetic field lines and about the right hand rule. Right hand rule, very importantly, right hand rule. Then Fleming's left hand rule, Fleming's left hand rule, and the domestic electric circuit, how the electric circuit will be there in the domestic electric circuit. That is the very important topic you have studied in this chapter, and some topics so that are deleted from this chapter, so that you know about the motors and generators. So this topic is not there for your syllabus. So only we are studying the two laws of the right hand rule, Fleming's law, Fleming's left hand rule, then domestic electric circuit. So these are the important topics. Okay, let us start with the first question. So first I will take the MCQ question. After that, I will start the short answer as well as long answer questions. Okay. The first question. The magnetic field lines inside a solenoid are in the form of parallel straight lines. The reason for this, the magnetic field inside the solenoid is the magnetic field lines in the inside the solenoid. So solenoid, this it is solenoid when it is connected to the electric circuit. When it is connected to the electric circuit, so this solenoid which act as a bar magnet alva. So this solenoid, it act as a bar magnet, and one pole that act as a north pole and another pole that act as a south pole. Here you know that you know about the bar magnet ಯಾವ ತರ ಇರುತ್ತೆ ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಅಲ್ವಾ. So in bar magnet, poles will be there, north and south poles, and magnetic field lines, how they are extended from one pole to the another pole ಅಲ್ವಾ. ಈ ತರ ಏನಾಗಿರುತ್ತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇರುತ್ತೆ ಅಲ್ವಾ. ಬಟ್ these magnetic field line inside the bar magnet, they are parallel ಅಲ್ವಾ. ಯಾಕೆ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಯಾವ ತರ ಇರುತ್ತೆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಲ್ಲಿ, ಇದೊಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಂದ್ರೆ, ಸೊ ದೇ ಲುಕ್ಸ್ ಲೈಕ್ ದಿಸ್, ಬಟ್ ಆಕ್ಚುಲಿ ಇಟ್ ಈಸ್ ಅ ಕ್ಲೋಸ್ಡ್ ಲೂಪ್ ಅಲ್ವಾ. ನೋಡಿ, ಸೊ ಆಕ್ಚುಲಿ ದಿಸ್ ಈಸ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅಲ್ವಾ. ಇಲ್ಲಿ ನೋಡಿ, ಇನ್ಸೈಡ್ ದ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ದೇ ಆರ್ ಪ್ಯಾರಲಲ್ ಅಲ್ವಾ. So they are straight lines and they are parallel. So here also in solenoid also, the reason for this, the magnetic field inside the solenoid is very high, uniform, zero, produced by electric current. The magnetic field inside the solenoid is the magnetic field inside the solenoid is uniform. Okay, so that is not very high, that is not zero, that is not produced by a electric current. The correct answer is option B. Next question. Observe the diagram. The magnetic poles represent by P and Q. So these are the P and Q respectively. Here we don't know which part is a north pole or south pole. We don't know that. So here option A, south, S and the south. So these both are S and S. And here north and south, north and south. Here north and north, north and north, and here south and north. South and north. Here P and Q represent what? Here P and observe this diagram, and here P and Q represent what? ಅಲ್ವಾ? ಇಲ್ಲಿ ನೋಡಿ ಕರೆಕ್ಟ್ ಆಗಿ ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಡಯಾಗ್ರಾಮ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಇಲ್ಲೇನ್ ಕಾಣಿಸುತ್ತೆ? So that is a bar magnet, and here the remaining all are the magnetic field lines ಅಲ್ವಾ? Magnetic field lines ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಾಗತ್ತೆ ಅಲ್ವಾ? So here just observe the magnetic field lines and their direction ಅಲ್ವಾ? So magnetic field lines ಏನಾಗಿರುತ್ತೆ? Here both are S. ಯಾಕೆ S? Both are S because always the magnetic field lines they extend from south pole to the north pole ಅಲ್ವಾ? ಇಲ್ಲಿ ನೋಡಿ ಈ ತರ ಏನಾಗಿರುತ್ತೆ, ಅದು ಸೌತ್ ಪೋಲ್ ಇಂದ ನಾರ್ತ್ ಪೋಲಿಗೆ, ಸೊ ಸಾರಿ ನಾರ್ತ್ ಪೋಲ್ ಟು ದ ಸೌತ್ ಪೋಲ್ ದೇ ಆರ್ ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಅಲ್ವಾ? ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಸೌತ್ ಪೋಲಿಗೆ ಈ ತರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ಎಕ್ಸ್ಟೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ನಾರ್ತ್ ಪೋಲ್. ಯು ಕ್ಯಾನ್ ಸಿ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡಿಸೈಡ್ ದ ಆನ್ಸರ್. ಗೊತ್ತಾಯ್ತಾ? ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅನ್ನ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ? ಸೊ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಡೈರೆಕ್ಷನ್ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂತ. ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಇಸ್ ಸೌತ್ ಅಂಡ್ ಸೌತ್. ಬೋತ್ ಆರ್ ಎಸ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ಸೌತ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ ನಾರ್ತ್. Next question. Which of the following correctly describes the magnetic field near the long straight wire? Here, which of the following represents the magnetic field of the long straight wire? Here, the field consists of straight lines perpendicular to the wire. The field consists of straight lines parallel to the wire. The field consists of radial lines originating from the wire. The field consists of concentric circles centered on the wire. So, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, which of the following correctly describes the magnetic field near the long straight wire? ಇಲ್ಲಿ ನೋಡಿ, ಒಂದು ಲಾಂಗ್ ಸ್ಟ್ರೇಟ್ ವೈರ್ ಏನಾಗಿದೆ, ಸೊ ದಟ್ ಕ್ಯಾರೀಸ್ ದ ಕರೆಂಟ್, which carries the current, and here magnetic field, how it is described here? The magnetic field lines consist of the concentric circles ಅಲ್ವಾ? ಸೊ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಪಾಸ್ ಆಗ್ತಾ ಇರಬೇಕಾದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಯಾವ ತರ ಇಲ್ಲಿ ಶೋ ಮಾಡುತ್ತೆ? ದಟ್ ಈಸ್ ಅ concentric circle centered on the wire. So this is centered on the wire. So the correct option is option D. Next question. At the time of short circuit, the current in the circuit reduces substantially, does not change, increases heavily, vary continuously. You know what is short circuit alva? So if the insulation of the wire they break down, then there is a both the wires, when the two wires they will combine and form the short circuit alva. So so which of the following is correct? When the short circuit occurs, it reduces the current in the circuit reduces substantially. No. Does not change. Yes, there is some changes occur alva. So it is also not correct answer. The correct answer is increases heavily. Option C is the correct answer, that is increases heavily. Next question. State the whether the following statements are true or false. Okay, just you have to write whether this sentence is true or false. The field at the center of the long circular coil carrying current will be parallel straight lines. So they are not, this is false. Because the field at the center of the long circular coil carrying current will be, they are not a parallel straight line. Second question, a wire with green insulation is usually the live wire of the electric supply. No, sorry. So this is correct. Okay, this is true. Sorry, this is true. The field at the center of the circular coil carrying the current will be parallel straight line. Yes, this is the correct sentence. Here, a wire with green insulation. Green insulation that represents the earth wire, right? That is not a live wire. That represents the earth wire is usually live wire of electric supply. This is false. Next question. Magnetic field is a quantity that has both dash and dash. A. Magnitude and direction. Only magnitude. Direction. Option D. None of this. Here, the magnetic field is a quantity which has both dash and dash means magnitude and direction. This magnetic field which has both magnitude and the direction. Okay, option A is the correct answer. Next question. An electric current through a metallic conductor produces a dash around it. So just imagine there is an electric current. So that is passing through the metallic conductor. This is the conductor. The electric current is passing through this. It produces what it produces around this wire. What it produces? It produces magnetic field, right? So it produces the magnetic field. So magnetic field is the correct answer. In our country, the potential difference between the two wires is 220 volt, 240 volt, 225 volt, 230 volt. So what is the potential difference between the two wires? That is, we know that that is the 220 volt in our country. Okay. So the potential difference is 220 volt. Option A is the correct answer. Next question. In right hand thumb rule, the thumb represents a magnetic field, direction of the current flow, direction of the magnetic field, none of this. So what it represents? Just the right hand thumb rule. You know that right hand thumb rule, alpha. So when you hold the current carrying conductor, so just imagine this is a current carrying conductor and you are holding this conductor, and see the direction of your thumb and the direction of your remaining fingers. Remaining four fingers direction ಅನ್ನ ನೋಡಿ, and see the direction of the thumb. So here they asked what is the uh, thumb represent here. So magnetic field, direction of the current flow, direction of the magnetic field, none of this. Here it represents the direction of the current flow, and the remaining fingers, they represents the direction of the magnetic field. So the how the magnetic field occurs in that current carrying conductor, it is represented by the thumb. Okay, remaining fingers. Okay. Next question. According to the Fleming's left hand rule, thumb represents direction of the magnetic field, direction of the current, force acting on a conductor, none of these. So, what the Fleming's left hand rule represents, or what it says. So, when the thumb, index finger, and the middle finger. So that is perpendicular to each other. When you hold it like this, when these three fingers are perpendicular to each other, so here this thumb represent what it represents. So when the current carrying conductor, so it is kept in a magnetic field, so it experiences the force acting on this, alva. So that thumb represents the force acting on the conductor. That is option C is the correct answer. Nodi, force acting on the conductor. That is option C. So see the answer here. So thumb, so that is the force acting on the uh, conductor, that is motion. So it represents the magnetic field, and it represents the middle finger, that represents the direction of the current. Okay. So till now we have discussed some important questions. Some questions they are from the uh, old question paper, and some are the important questions can be asked from this question. So like that we have discussed the some question from this chapter. Okay, so next we are discussing the 1 mark as well as the long answer questions. Okay, so let us start with the first question. List two methods of producing the magnetic field. So how we can produce the magnetic field? Yes, by using the magnets, bar magnet, alba. By using the magnets, we can produce the magnetic field. Or when the current passes through the conductor, it produces the magnetic field. Correct answer is by using a magnet, by using a electric current. When you pass the electric current through the conductor, it act as a it produces the magnetic field. Yes, always the magnets they are producing the magnetic field. So these are the two methods of producing the magnetic field. Okay. When does an electric short circuit occur? When does, so how it happens? When it happens? Here, if the insulation of the wires are damaged, the current carrying conductor, they are insulated by some ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಅಲ್ವಾ. ನೀವು ಕರೆಂಟ್ ಕ್ಯಾರಿ ಮಾಡೋ ವೈರ್ ಅನ್ನ ನೋಡಿ ಹಾಗೆ ಓಪನ್ ಆಗಿರತ್ತಾ? ಇಲ್ಲ, ಅದ್ರ ಸುತ್ತಲೂ ಏನಿರುತ್ತೆ, ಸೊ ದರ್ ಇಸ್ ಎ ಕವರ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಎ ಇನ್ಸುಲೇಷನ್ ಅಲ್ವಾ. ಆ ಇನ್ಸುಲೇಷನ್ ಏನ್ ಮಾಡುತ್ತೆ, ಇಫ್ ದ ಇನ್ಸುಲೇಷನ್ ಗೆಟ್ damaged, then what happens? So there is a chance of short circuit. There is a fault in a electric appliances. If there is a fault in a electric appliances, there is a chance of the electric short circuit. Next question. Observe the figure and mention the direction of the force acting on the current carrying conductor AB. Name the rule that help you find the direction of the force. Here, just observe this setup. There is a horseshoe magnet, so that is having the south and north pole, and the current carrying conductor that is kept in between these two poles, south and north pole, and this current carrying conductor that is connected to the battery. Here you can see the battery and see the direction of the current flow. So it is flowing in this direction. It is the direction of the current flow. Then, so just observe this. Again, there is a magnetic field, and there is a the current is flowing in this direction from B to A ಅಲ್ವಾ. ಏನಾಗ್ತಾ ಇದೆ, ಕರೆಂಟ್ ಏನಾಗ್ತಾ ಇದೆ, B to A. So it is passing. Name the rule help to find the direction of the force. Here, you know the direction of the current. Which rule you will apply to find out the direction of the force? That is Fleming's left hand rule. Left hand rule ಏನು ಹೇಳುತ್ತೆ ಹಾಗಾದ್ರೆ? What left hand rule says? Here, when you hold these three fingers, thumb, index and middle finger, so they should be perpendicular to each other, and the middle finger, so that represents the direction of the current flow, and the index finger that represents the magnetic field, and the thumb that represents the force in which the direction of the force alva. ಇಲ್ಲಿ ನೋಡಿ, uh, we know the direction of the current from B to A alva. Then, so name the rule to help the find the direction of the force here. So that is the Fleming's left hand rule. Left hand rule. Here, you know the direction of the force, sorry, direction of the current. Then at what direction the current carrying conductor experience the force? So at what direction? So in this direction, alva. So e direction alli enagatte alli. So that is experiencing the force. So that is at the left direction, alva. If you change the direction of the current change ಮಾಡಿದಾಗ ನೋಡಿ, current direction ಈಗ B to A ಇತ್ತು, ಈಗ A to B ಆದ್ರೆ ಏನಾಗುತ್ತೆ, ಮತ್ತೆ direction of force also changes. So that is in the opposite side. So ಆ ರೀತಿಯಾಗಿರುತ್ತೆ. Next question. What is solenoid? What is solenoid? Write the properties of the magnetic field lines formed around the current carrying solenoid. Here, the option B, question number B, what is alternating current? Electric appliances having metallic body are connected to earth wire. Why? Here, first, let us see the first question. What is solenoid? Okay. What is solenoid here? A solenoid is a coil of wire. So that is a coil of wire designed to create the magnetic field. Coil of wire. So when the electric current passes through it, so just connect it to the battery. When the electric current passes through it, often used in a, so this is used in a electromagnets. Okay, so this is a solenoid. Then, so this solenoid, just I will draw it again. This solenoid, it acts as a bar magnet. When the current passes through this, this act as a bar magnet. Here, you should know the characteristics of the bar magnet and the magnetic field lines which are formed around the bar magnets, alva. So the same characteristics will be there. What are the properties of the magnetic field lines that are formed around the current carrying conductor? Here, what are the characteristics? The field lines emerge from North Pole and the merge at the South Pole. ಅಲ್ವಾ? ಸೊ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಎಮರ್ಜ್ ಆಗಿ ಸೌತ್ ಪೋಲ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸೊ ದೇ ವಿಲ್ ಮರ್ಜ್. Then the direction of the field lines is from its south pole to the north pole. South pole in the north pole irutte alva. Then the magnetic field lines are closed curves. The magnetic field lines which are formed around the solenoid, they are closed curves. Okay. Then magnetic field lines never intersect each other. The magnetic field lines, they will not never intersect each other. So these are the characteristics of the magnetic field lines which are produced around the solenoid. Then what is alternating current? So about this topic is, this question is deleted, so I will not discuss this one. Next, electric appliances having metallic body are connected to earth wire. Why? Why they are connected to the earth wire? Answer for this question. The metallic body is connected to the earth wire. The earth wire, which provides a low resistance conducting path for the current, and thus it ensures that the leakage of the current to the metallic body of the appliances keeps it potential to that of the earth, and user may not get the severe electric shock. That is that's why it is important to connect the earth wire. Next question. What are the reasons occurring overload in an electric circuit? I hope you know this word overload ಅಲ್ವಾ. ಸೊ ಓವರ್ಲೋಡ್ ಅನ್ನುವಂಥ ಒಂದು ವರ್ಡ್ ಅನ್ನ ನೀವು ಕೇಳಿರ್ತೀರಾ. ಸೊ ವಾಟ್ ಆರ್ ದ ರೀಸನ್ಸ್ ಫಾರ್ occurring the in an electric circuit? Overload in an electric circuit. Overload can occur when the live wire and the neutral wire come into direct contact. So there are three types of the wire: earth wire, live wire, and the neutral wire. So here, when the live wire and the neutral wire come into direct contact, so when it occurs, when the live wire ಮತ್ತೆ neutral wire ಯಾವಾಗ contact ಗೆ ಬರುತ್ತೆ, ಇದು ನೋಡಿ, I'll just imagine. This is the live wire, okay? And I will take another color. So this is the neutral wire. Here, when they are come into contact, so the contact ಗೆ ಬಂದಾಗ overload ಆಗ್ಬಿಡತ್ತಾ? ಇಲ್ಲ. If the insulation is removed, if insulation is damaged, ಇದ್ರ ಸುತ್ತ ಏನಿರುತ್ತೆ? Insulatory covering ಇರುತ್ತೆ ಅಲ್ವಾ? So if it is damaged, then there is a chance of the come in contact in another wire, so it causes the overload. And overload can also occur due to an accidental hike in the supply voltage. So sometimes you know that 220 volt is the uh, in our country, this is the voltage, so what we used in our house. But if it is 240 volt supply, if the supply voltage increases, so then also there is a chance of the overloading. If too many appliances are connected to the single socket, so ತುಂಬಾ ಒಂದು appliances single socket ಗೆ connect ಆದರೆ there is also be a chance of overloading. Next question. List the properties of the magnetic field due to the flow of electric current in solenoid. What are the two methods of increasing the magnetic field in a solenoid? So here they asked, so you know that last question ಏನಿತ್ತು, magnetic field lines characters ಅನ್ನ ಬರೀರಿ ಅಂತ ಇತ್ತು ಅಲ್ವಾ. But here they asked list the properties of the magnetic field due to the flow of the electric current in a solenoid. So what type of the magnetic field is produced, how it is, so that characteristics you have to explain. What are the two methods of increasing the magnetic field in a solenoid? First question. So the what are the characteristics of the magnetic field in a solenoid? Here, similar to a bar magnet, has north and south pole. So that solenoid magnetic field that is similar to the bar magnet. So which is similar to the bar magnet. Alva bar magnet ಈ ತರ ಇರುತ್ತೆ. ಇದಕ್ಕೆ ಸಿಮಿಲರ್ ಆಗುತ್ತೆ. Which has the north and south poles. So it this solenoid is used to magnetize the other material alva. So to magnetize the other material, it is used uniform magnetic field at the center. The magnetic field is uniform at the center. So this magnetic field is uniform at the center, and they have the magnetic field lines. So they also have the magnetic field lines. So that is the imaginary lines. So these are the characteristics of the magnetic field, the properties of the magnetic field due to the flow of electric current in a solenoid. Okay. Next question. How we can increase the uh, method of increasing the magnetic field in a solenoid? Magnetic field ಅನ್ನ solenoid ಅಲ್ಲಿ ಯಾವ ತರ increase ಮಾಡಬಹುದು ಅಂತ ಅಲ್ವಾ? So here increasing the number of turns in the coil, more turns result in a stronger magnetic field for the same current, and increasing the current through a coil, so that is a higher current produces the stronger magnetic field for the same number of turns. Means more current passes through that coil, it produces the stronger magnetic field. So these are the two methods of increasing the magnetic field in a solenoid. Next question. Lines do not intersect each other. Why? You know the magnetic field lines. So just imagine this is the bar magnet, and so this magnetic field lines will be like this ಅಲ್ವಾ ಈ ತರ ಇರುತ್ತೆ, but they are not like this. Are they intersect like this? No, they will not intersect like this. What is the reason behind this? Why magnetic field lines do not intersect each other? Here the magnetic field lines do not intersect each other because if they did, if any two magnetic field lines are intersecting like this, it would mean that at that point of intersection, they would be two different direction for the magnetic field, which is not possible. So they are not in the two different direction in that magnetic field. Each point in a magnetic field has one direction of the field. So the lines remain separate and never cross. So ನೀವು ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅನ್ನ ಯಾವ ತರ ಡ್ರಾ ಮಾಡೋದು ಅಂತ ಗೊತ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು ಕ್ರಾಸ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ನಾಟ್ there would be a two different direction. So ಅಲ್ಲಿ for that magnetic field ಬೇರೆ magnetic field direction ಅಲ್ಲಿ ಇರಬಹುದು ಅದು ಅಲ್ವಾ? So because of this reason the magnetic field lines they will not cross each other. So which is one of the important question. So for 2 marks it can be asked. 2 marks ಗೆ ಕೇಳಬಹುದಾದಂತ question. Next question. What are the functions of earth wire? It is necessary to connect electric appliances having the metallic body to the earth wire in domestic electric circuit. Why? Explain. What are the functions of the earth wire? Earth wire, so that is the function of the earth wire is to provide the safe path for the electric current to flow into the ground in case of the fault. So that is the function of the um, earth wire. So in case if any it is necessary, why it is necessary to connect the electric appliances to the earth wire? If any excess current is there or overloading is there at that time, so that uh, uh, prevent the electric shock or reduces the risk of electrical fires and ensures the safety of both electrical appliances and users. So what is the use, why we should use that, why electric appliances should be connected to the earth wire? So because of the it helps to prevent the electric shock, reduces the risk of the electric fires, and ensures the safety of both electrical appliances and the users. So that is why the uh, electric appliances should connected to the earth wire, which is having the metallic body. They should connect to the earth wire. Next question. How does overload and short circuit occurs in an electric circuit? ನೋಡಿ ಈ ಓವರ್ಲೋಡ್ ಇರ್ಬೋದು, ಎಲೆಕ್ಟ್ರಿಕ್ ಸರ್ಕ್ಯೂಟ್ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಇರ್ಬೋದು, ಆರ್ what are the functions of the fuse, magnetic field lines properties. So these all are repeatedly asked question and very important questions. Here, how does overload and short circuit occurs? First thing, overloading occurs when too many electrical devices connected to a circuit drawing more current than the circuit is designed to handle. When more than two or many devices are connected in a single circuit, ಆ circuit ಅಲ್ಲಿ ಅಷ್ಟು current ಏನಾಗೋದಿಲ್ಲ, so that is not able to handle, so that is not which is not having that much current, so drawing more current than the circuit designed to handle. So this excessive current can cause the overloading, okay, so of the wiring and potentially lead to the electrical fires. So overloading can also occur due to the accidental hike in the supply of the voltage. So voltage supply ಒಂದೇ ಸಲ ಜಾಸ್ತಿ ಆಗ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ, there is a chance of the overloading. And last one already we have discussed in the first point, that is occurs due to the electrical devices connected to the circuit. Too many electrical devices connected to the circuit. Then what is short circuit? How it occurs? Short circuit occurs when a direct connection is made between the 2 points in a circuit with the different electrical potentials bypassing the intended load. Or it can be, the short circuit can be occurred due to the damage of the when the two earth wire the live wire and neutral wire come in contact due to the loss of the insulation present on them, so it creates the short circuit. So here the current flow suddenly increases, which can cause the overheating or damage of the components and electrical fires. Next question. What is the use of the electric fuse? ಇದ್ರ ಬಗ್ಗೆನೂ ತುಂಬಾ ಸಲ ಕೇಳ್ತಾರೆ, very important. What is the use of the electric fuse in an electric circuit? The use of an electric fuse prevents electric circuit from the or electric appliances from the possible damage by stopping the flow of the high electric current, unduly high electric current. A fuse ಏನಾಗ್ಬಿಡತ್ತೆ, so that is stopping the flow of the current to the electric appliances. ಆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗೋದನ್ನ ಸ್ಟಾಪ್ ಮಾಡಿ, ಸೊ ಅಲ್ಲಿ ಆ ಒಂದು ಅಪ್ಲಿಯನ್ಸಸ್ಗೆ ಡ್ಯಾಮೇಜ್ ಆಗೋದನ್ನ ಆರ್ there is a chance of breakdown of the circuit, so it is also prevented. A joule heating that takes place in the fuse melts it to break the electric circuit. So very important question. Suggest any two measures to avoid the overloading in domestic circuit. How we can avoid the overloading in the domestic circuits? Avoid connecting too many appliances to the single socket ಅಲ್ವಾ. ಸೊ ಟೂ ಮೆನಿ ಅಪ್ಲಿಯನ್ಸಸ್ ಅನ್ನ ಒಂದೇ ಕಡೆ ಒಂದೇ ಒಂದು ಸಾಕೆಟ್ಗೆ ಏನ್ ಮಾಡಬಾರ್ದು, ಕನೆಕ್ಟ್ ಮಾಡಬಾರ್ದು. ದಟ್ ಕ್ಯಾನ್ ಕಾಸ್ ದ ಓವರ್ಲೋಡಿಂಗ್. ಆ್ಯಂಡ್ ಯೂಸ್ ಆಫ್ ದ ಫ್ಯೂಸ್ ಅನ್ನ ಕನೆಕ್ಟ್ ಮಾಡೋದ್ರಿಂದ ವಿ ಕ್ಯಾನ್ ಪ್ರಿವೆಂಟ್ ದ ಡ್ಯಾಮೇಜಿಂಗ್ ಆಫ್ ದ ಸರ್ಕ್ಯೂಟ್ ಆಸ್ ವೆಲ್ ಆಸ್ ದ ಡ್ಯಾಮೇಜಿಂಗ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಅಪ್ಲಿಯನ್ಸಸ್. What does the thumb indicate in the right hand thumb rule? Here, what does the thumb indicate? See the diagram. So this is the current carrying conductor, and so this is the magnetic field produced around the current carrying conductor. ಇಲ್ಲಿ ಕರೆಂಟ್ ಕ್ಯಾರಿ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ, ಈ ಕರೆಂಟ್ ಕ್ಯಾರಿ ಆಗ್ತಾ ಇರುವಂತ ಕಂಡಕ್ಟರ್ ಸುತ್ತಲೂ ಏನಾಗ್ತಾ ಇದೆ, so there is a formation of the magnetic field and it represents the how it is holded. So at that direction the magnetic field direction will be there. So here what it the thumb represents the direction of the current. Thumb represents the direction of the current. Next question. An electric oven of 2 kilowatt power rating is 2 kilowatt power rating is operated in a domestic electric circuit, that is the 220 volt, that has current rating uh, 5 ampere. What is the result do you expect? Explain. Okay. So what is the power? P is equal to 2 kilowatt. Alva, 2 kilowatt means what is, how many watts? That is 2000 watts. Then V is equal to 220 volt, and so they had given the I is equal to 5 ampere current. So here P is equal to V into I formula, we know that is the power formula. So just find out the what is the current drawn by that apparatus. I is equal to P by V. So that is 220, sorry, 2000 divided by 220. So around 9 ampere current is drawn, but yes, here P is equal to VI formula. P is equal to 2 kilowatt means 2000 watt. V is equal to 220. So we should know the current flow. So the current flow, that is I is equal to P by V formula. So we know 2000 divided by 220, that is around 9.09 ampere. So here the electric appliances that draw the 9 ampere current, but here all, so the capacity is only 5 ampere. So the current drawn by this electric oven is 9 ampere. The current drawn actually is, that is 9 ampere, whereas the fuse in the circuit is only 5 ampere capacity. So that is having only 5 ampere capacity. When high current of 9 ampere flows through the 5 ampere fuse, the fuse wire will get heated too much and melt and break the circuit. So that fuse that break the circuit, it is not possible. Okay. So this is the correct answer. Next question. What are the precautions should be taken to avoid the overloading of the domestic circuit? So already we have solved this question. Here we should not connect the too many. Okay. Each appliance has separate switch to on off the flow of current through it. And the use of an electric fuse prevents the electric circuit and the appliances from the possible damage. We have to use the electric fuse, and we should not connect the too many appliances for the single socket to prevent the overloading. That is the correct answer. Next question. How does a solenoid behave like a magnet? Determine the north solenoid with the help of bar magnet. Explain. How does solenoid behave like a bar magnet? The first question. One end of the solenoid behaves as a magnetic north pole, while the other behaves as a south pole. The field lines inside the solenoid are uniform. They are uniform and they are parallel straight lines. This indicates that the magnetic field is same at the points inside the solenoid. Okay. And how it is act as a bar magnet? As shown in the figure, so I will show the diagram here. So this is the solenoid. Magnetic field produced inside the solenoid can be used magnetize the piece of magnetic material. So the magnetization is done inside the this solenoid, and the magnet which is formed due to this, that is called as a electromagnet. So here you can observe the how the solenoid act as a bar magnet. Okay, how it act as a bar magnet, because it is having the magnetic field lines, and they are um, parallel inside the magnetic field lines, and they are one pole act as a north pole and another act as a south pole. So this is to make the how to magnetize the other materials like iron. Okay. When is the force experienced by current carrying conductor placed in a magnetic field is largest? So when it is largest, if the direction of the magnetic field and flow of the electric current are mutually perpendicular, then the force experienced by the current carrying conductor in a magnetic field is largest. So if both magnetic field and flow of the current, so they are the direction of the magnetic field and the flow of the electric current, so that is the Fleming's left hand rule, alva. So when they are mutually perpendicular, then the force experienced by the current carrying conductor in a magnetic field is largest. So the force experienced is largest. Okay. Next question. State the rule to determine the direction of a magnetic field produced around the straight conductor carrying current. The magnetic field which is produced around the straight current carrying conductor, that is by the right hand thumb rule, alva. So that is by the right hand thumb rule. If the current carrying conductor is held in the right hand, so already we know this rule, the thumb points in the direction of the current, and the direction of the uh, then the direction of the current of the remaining fingers, that the curl of the fingers, that will represents the direction of the magnetic field. Here, second one, force experienced by a current carrying straight conductor placed in a magnetic field which is a perpendicular to it. So this is the Fleming's left hand rule, alva. So Fleming's left hand rule ಏನು ಹೇಳುತ್ತೆ, stretch the finger, forefinger and the central finger and the right hand of the left hand. Okay, left hand mutually perpendicular to each other. If the forefinger uh, points the direction of the magnetic field, the central finger in the direction of the current, and then the thumb points the direction of the force in the conductor. So that is the Fleming's left hand rule. When does an electric short circuit occur? Already we know the answer for this question, alva. Overloading can occur when the live wire and the neutral wire come into direct contact. So in such situations, current in the circuit abruptly increases. This is called as a short circuiting. So already we know the answer for this question. Already we have discussed the answer. What is the function of the earth wire? Why it is necessary to connect the earth metal to connect the earth wire? So the metallic appliances. Why the metallic appliances? They should connect it to the earth wire, alva. So one of the very important questions. So repeatedly ಈ questions ಅನ್ನ ನಿಮ್ಗೆ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. So this what is the function of the earth wire? So earth wire, when it is connected, so that is helpful for the which is having the metallic body, the appliances which are having the metallic body, electric, for example, electric press or toaster, fan, etc. It provides the low resistance and conducting path for the current. Thus, earth wire ensures that any leakage of current to the metallic body of the appliances keeps it potential to that of the earth, and user may not get severe electric shock or electric fire, so like that. So it prevents the users. Okay, so that is the importance of the this earth wire. ಎಕ್ಸ್ಪ್ಲೇನ್ ದ ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್. ಇದನ್ನ ನಿಮಗೆ ರಿಪೀಟೆಡ್ ಆಗಿ ಕೇಳ್ತಾರೆ, ಆರ್ ದ ವಾಟ್ ದ ರಿಮೈನಿಂಗ್ ಫಿಂಗರ್ಸ್ they will indicate, or what is the direction of the current is represented by which finger. So like that they will ask the question. 1 mark ಮತ್ತೆ 2 mark ಗೆ ಕೇಳ್ತಾರೆ. The right hand thumb rule states that if you hold a current carrying wire in your right hand with your thumb pointing in the direction of the current, then the direction of your fingers curling indicates the direction of the magnetic field lines around the wire, and this thumb indicates the direction of the current. This is the right hand thumb rule. So this can be asked for 2 mark question. So ಈ diagram ಅನ್ನ ನೋಡಿಟ್ಕೊಳ್ಳಿ. So that will be helpful to write the right hand thumb rule. Next question. Explain the Fleming's left hand rule. Left hand rule ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಅಲ್ವಾ? Here in the Fleming's left hand rule, when you stretch your left hand's thumb, index finger and the middle finger, so they are perpendicular to each other. The index finger that points the direction of the magnetic field, and the middle finger that indicate the direction of the current, and the thumb that points in the direction of the force acting on the conductor. So this is the Fleming's left hand rule. List the properties of magnetic field lines. ಒನ್ ಆಫ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್. ಇದನ್ನ 2 mark ಕ್ವಶನ್ ಆಗಿ ತುಂಬಾ ಸಲ ರಿಪೀಟೆಡ್ ಆಗಿ ಕೇಳಿರ್ತಾರೆ. ಸೊಲೆನಾಯ್ಡ್ ಬಗ್ಗೆ ಇರಬಹುದು, ಅಥವಾ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್, ಅರ್ತ್ ವೈರ್, ಓವರ್ಲೋಡಿಂಗ್, ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್. ದೀಸ್ ಆಲ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ಸ್ ಬಿಕಾಸ್ ರಿಪೀಟೆಡ್ಲಿ ಕ್ವಶನ್ಸ್ ಆರ್ ಆಸ್ಕ್ಡ್ ಆನ್ ದಿಸ್ ಟಾಪಿಕ್. ನೋಡಿ, magnetic field lines are continuous curves that form the closed loops. The magnetic field lines originate from the north pole and end at the south pole. ನಾವು ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಕ್ವಶನ್ ನೋಡಿದ್ವಿ ಅಲ್ವಾ? ಸೊ ಏನಾಗಿರುತ್ತೆ, ಎರಡು ಈ ರೀತಿಯಾಗಿ ನಿಮಗೆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ರು. ಈ ತರ ಏನ್ ಮಾಡಿದ್ರು, ಸೊ ದೇ ಹ್ಯಾಡ್ ಗಿವನ್ ದ ಡೈರೆಕ್ಷನ್ ಅಲ್ವಾ? ಸೊ ಈ ಪೋಲ್ ಯಾವುದು ಅಂತ ಕೇಳಿದ್ರು ಅಲ್ವಾ? ಸೊ ಯು ನೋ ದಟ್ ಆಲ್ವೇಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ದೇ ಆರ್ ಡೈರೆಕ್ಟೆಡ್ ಫ್ರಮ್ ನಾರ್ತ್ ಟು ಸೌತ್ ಪೋಲ್ ಅಲ್ವಾ? ಸೊ ಇಲ್ಲಿ ಈ ತರ ಇತ್ತು. ಸೊ ದಟ್ ಈಸ್ ನಾರ್ತ್ ಟು South Pole alva. Magnetic field lines are more crowded near the poles where the magnetic field is stronger. Magnetic field ಎಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಪೋಲ್ ಅಲ್ಲಿ ಅಲ್ವಾ? ಎಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಜಾಸ್ತಿ ಇದೆಯೋ ಅಲ್ಲಿ, ಸೊ ದೇ ಹ್ಯಾವ್ ದ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. Magnetic field lines never cross each other. They will not intersect. Next question. See the Is it possible to connect a 1300 watt refrigerator to a 5 ampere rated plug in the 220 volt household electric circuit? Explain your answer. Here, you know that P is equal to VI formula. Here P is given, that is 1320 watt, and V is also given, that is 220 volt, and I is given, that is 5 ampere alva. So that is they are connected to the 5 ampere. So we have to find out current drawn by this refrigerator alva. ಎಷ್ಟು current ಬೇಕು ಅನ್ನೋದನ್ನ ನಾವು ಇಲ್ಲಿ find out ಮಾಡಬೇಕು. So I is equal to P by V formula I will put here. P is 1320. Here this is V is 220. I will cancel 1 and 11 6 so I is equal to 6 ampere. So it is not possible because here a 5 ampere rated plug use ಮಾಡಿದ್ದಾರೆ ಅಲ್ವಾ ಇಲ್ಲಿ 5 ampere rated plug is used, but here the current drawn is 6 ampere. So it is not possible to connect the, yes, so that is the 6 ampere. So it is not possible to connect the 1320 watt refrigerator to the 220 volt household electric circuit with 5 ampere fuse because it need 6 ampere ಅಲ್ವಾ 6 ampere ಬೇಕು. So 5 ampere fuse ಜೊತೆ ಏನಾಗೋದಿಲ್ಲ. So that is not able to connect. That is the correct answer. Okay. So students, we have discussed some important questions on this chapter. So if you have any doubts, you can ask or you can write down in the comment box. Okay. Thank you. We will meet in the next session.